In number 50, we're going to do a word problem. Notice that we are allowed to use our calculator for this problem. This is the problem of a quadratic. It's a situation of something being shot into the air. It includes the force of gravity with negative 16t squared, an initial velocity of positive 56t, and an initial height of 32 feet. Our equation h of t can be put into the calculator in y equals, where h is our dependent variable y and t is our independent variable x. We'll do a quick sketch just to show what we are expecting here, and that is that the arrow is going to go up and eventually come down. Notice it starts at initial height of 32 feet. We can label the axes, height for the dependent variable in feet, and time in seconds for the independent variable. Notice that there are at least 2 points of interest here, one being the maximum and 2 being the 0 or x-intercept. This is the maximum height that the arrow can reach, and this is how long it takes for the arrow to come back down to the ground. Now let's put this in our calculator and take a look. I'm going to suggest a window that's just slightly different than the standard window at zoom 6. The only value that will need to be changed is y max. And if you set that at a 100, the graph will be easy to look at. Our first question in A is how many seconds will it take for the arrow to hit the ground? We're going to use second trace, and under this, a feature number 2 called 0. When you hit number 2, it's going to ask for a left bound, and we're going to move our cursor from the y-axis, where it can normally be found, around to the x-intercept that we're trying to find. It's asking for a left bound, so we want to pick a point slightly to the left of the point we're trying to find, and hit enter. We'll then move to the right of the point that we're trying to find, and hit enter for the right boundary. The third time when the calculator says guess, just hit enter again, and it will return the value 4, 0. This answers the question, how many seconds will it take for the arrow to hit the ground? And the answer is 4 seconds. In part B, how high will the arrow be at t equals 1.5 seconds? There's a couple different ways to go about answering this question. One would be to plug in the value 1.5 into the equation and just get out an answer. Second one would be to look it up in the table in your calculator, and you'd have to look at an independent variable or t value of 1.5 seconds. In order to have decimal values in your calculator, you'll have to change your table, go to table setup and change your table start to 0, for instance, and the change in table to 0.5. This will allow you to see values in between the whole numbers. A third way to find this value is to use second trace. Again, just as we did in the previous part, except this time we'll use number 1 value. When you hit number 1, the calculator asks you x equals, and you can just put in the number 1.5 and hit enter. When you do this, it returns the value 80. So our answer to how high will the arrow be at t equals 1.5 seconds is that it will be 80 feet high. The third question, what is the maximum height in feet that the arrow will reach, can be answered using second trace Number 4, maximum. Again, it's going to ask us for a left bound and then a right bound on either side of our maximum point. The third time when it asks guess, just hit enter again, and it will return the value for the maximum, which in this case is 1.75 seconds and 81 feet. Therefore, the maximum height in feet that the arrow will reach is 81 feet high. Notice that this question is a grid in. So in each case, we need to fill in the grids. The number that you put at the top is actually there just for you. It's truly the number that gets gridded in, the circles that get filled in, that the computer reads. So make sure that you fill in your circle completely. It's okay to write the answer left justified or right justified. Completely up to you, as long as the full answer fits into the boxes. Remember, you can only put in fractions or decimals if they are allowed in the grid.